Hello everyone. Today we are going to discuss about measures of central tendency. These measures of central tendency are very basic concepts in statistics. The reason to say them very basic concept because based on these measures, most of the other inferences and other statistical measures are carried out in statistics. So other statistical measures can be like skewness, kurtosis, standard deviation, even normal distribution can be calculated based on these measures. Even some machine learning algorithms like linear regression uses these measures for the calculation purpose for the formula. So in this particular session, we are going to discuss about following things like what is the central tendency measures, why do we need it, what are the different measures available, and then we will see how to calculate these measures. But this calculation part, the formula part, we will see in the next session. Now let's see what do we mean by central tendency measures. What is the definition of it? So central tendency, we can say that it denotes a single point or a central value of all the data points. Okay, so by the mean of central tendency, it denotes a central point, a central position, or a single value which will represent all the data points. Okay, so it will provide us the summarized overview of all the data points, and we can say that it will represent entire data. Before we proceed further, when I say that all the data points, for that purpose, you can consider any one-dimensional array as data points which will contain different numeric values. For example, over here, you can consider this particular data frame having some exam marks, like over here it is mathematics and English marks. So over here, this mathematics column having some numerical values can be considered as different data points having different numerical values. Okay, so this particular column mathematics contain different marks of different students. So you can consider this column as data points column. So when I say data points, I'm referring to any one-dimensional array which contains some numerical values. Now let's see what are the different measures available in statistics. So in statistics, we have three different measures available: mean, mode, and median. Again, within mean, we have three more different types like arithmetic mean, geometric mean, and harmonic mean. Now, if we talk about mean, so mean will be highly impacted by outliers. And if we see the relationship in the context of outlier, then arithmetic mean will be greater than geometric mean, and geometric mean will be greater than harmonic mean. It means that arithmetic mean will be highly impacted by outliers compared to harmonic mean. Again, if we drill down more, then we can see that arithmetic mean will be highly impacted by large numbers, whereas harmonic mean will be least impacted by large numbers. On the contradictory side, arithmetic mean will be least impacted by small numbers, whereas harmonic mean will be highly impacted by small numbers. Okay, so just to give an overview, that let's say I have numbers ranging from 1 to 100, and if we are going to have one more number which might be in crores, so the arithmetic mean will be highly impacted by that crores value. On the another side, let's say I have data points in the range of crores, and let's say I have some value in some 0.00005. In that case, my harmonic mean will be highly impacted by that small value. Okay, and this mean will be known as mathematical average. Now let's talk about median. So median is a central point or central position of all the data points in such a way that it will separate all the data points in two equal sections, such that upper half and lower half, and this distribution will be equally in both the parts. So over here we can say that 50% data points will be in upper half, and other 50 point data point, sorry, another 50% data points will be in the lower half. And based on the equation of median, we can say that it is being known as positional average. Okay, and like based on the equation as well, we can say that it will be least impacted or not impacted by the outliers. Next, we will talk about mode. So mode will be the number which will have highest number of frequencies, such that any data point which will be repeated highest number of times, and that data point will be considered as a mode. Okay, and also it is being known as positional average. Now let's see that why do we need these central tendency measures. So there are basically three reasons for which we will need measures of central tendency. First is to get summarized view of the data. So to get summarized overview of all the data points. Second is to compare different groups having different characteristics. And third one is to compare an individual from a group with the group itself. So this is the three requirements where central tendency measures will be required. Now the question might be there, like, okay, if what if two different groups have same central values? So yes, definitely it is possible that different groups will have same central values. And in such kind of cases, CTM, such that central tendency measures, won't be suffice for the comparison purpose. And in all those cases, we will need measures of dispersion as well. Now, apart from central location of data, apart from summary statistic, or apart from overview of all the data points, CTM won't provide much more meaningful information, and hence it is advisable to use CTM with the measures of dispersion like standard deviation, skewness, kurtosis, variance, etc. And as I have mentioned earlier, that based on CTM, we can have different measures being calculated. Those are like skewness, kurtosis, normal distribution, etc. But yeah, one thing that we can say that with this central value, we can say that all the data points will be distributed around the central value. But again, how far or how near these data points will be from that central position, that can be known with the help of measures of dispersion like standard deviation, skewness, kurtosis, etc. To understand it, consider a line like this. Over here it has a values from 0 to 100, and let's say over here my central position, central point is there having value of 50, and over here we have different data points like 10, 20, 30, 40, etc. And same way over here we will have 60, 70, 80, 90, etc. Now with the help of this measures of central tendency, we can say that all these data points will be distributed around this central value. But how far or how near these data points will be from this central location can be known with the help of measures of dispersion. So this is where we will need measures of dispersion, and definitely we are going to discuss them in coming few sessions. Now let's understand mean, mode, and median and how to interpret them, how to draw a conclusion in the context of one example. And this example is about considering 100 students giving exam of English and Maths of 100 marks. So first we will talk about mean value. So consider that in English the average marks are 80, and in mathematics the average marks are 50. Now, based on these details, we can say that 100 students mark in English will be around 80, and 100 students mark in mathematics will be around 50. Again, how far or how near these marks will be from these central values can be known by measures of dispersion only. So it will only show central position of all the data points. Now over here, based on these mean values or average marks of English and mathematics, we are comparing two different groups, such that English and mathematics. So based on these average marks, we can say that students are good in English compared to mathematics. Or another interpretation that we can have is English paper was easier compared to mathematics paper. So this was about comparing two different groups based on the central value. Next thing is comparing an individual from a group with the group itself. So over here, we have a student having 80 marks in mathematics. Okay, so over here, what can we say that the student has got good marks compared to average marks? The student is doing good above an average, and the student is good in mathematics. So these are the different conclusions that we can have based on this average marks and comparing it with an individual's mark. So this is how we can interpret average. Next, we will talk about median. So as I have mentioned earlier, that median will divide all the data points into equal half, such that upper half and lower half. Okay, so over here, consider that my median marks in mathematics is 50. Just for your reference, over here, we are considering normal distribution of all the data points. It means that marks in mathematics and English are following normal distribution. And in such cases, in the case of normal distribution, mean, mode, and median all will have equal values. So it normal distribution, mean, mode, and median will be equal. Okay. So with the help of median value 50 in mathematics, we can say that a student is in lower half or in upper half. Okay, so that is the one interpretation that we can have. Also, we can say that 50% student will have marks less than or equal to 50, and other 50% student will have marks greater than or equal to 50. And if any student has got 80 marks in mathematics, we can state that the student is doing good than 50% of the students, such that lower half of the students. And now how we have come to this conclusion that 50% student will have marks greater than or equal to 50 and 50% student will have marks less than or equal to 50, that we will see in the equation session, in the formula session. So mode will be the number having maximum frequency of any number or maximum frequency of any grade. Okay, so here consider that mode marks in mathematics is 50, similar to mean and median marks. As I have stated, that we are considering that it will follow normal distribution, and in normal distribution, mean, mode, and median will be equal. So they will have same values. So over here, mode will also have same value of 50. So when we say that mode equal to 50, it means that the frequency of 50 marks in mathematics is high compared to any other marks. We can say that the frequency can be 2 or maybe more than 2. So it means that 2 students or more than 2 students have got 50 marks in mathematics. It is not necessary that mode can be a single value only. It can be of multiple value as well. So for example, if 5 students has got 50 marks, another 5 student has got 60 marks, and another 5 student has got 40 marks, we can say that we have 3 modes, so that 40 marks, 50 marks, and 60 marks. So this is how we can interpret mode. Now, how to calculate this mean, mode, and median with like geometric mean, arithmetic mean, and harmonic mean. So for that, the formula portion we will see in the next session. But yes, if you want to know that how to calculate this mean, mode, or median, such that central tendency measures with the help of Python and R, so for that I have uploaded the codes on GitHub link and GitLab link. So I have provided both the links in the description box. Please check it out. I have provided this English mathematics marks in Excel sheet as well on the same link. So on the same link, you will be able to get this Excel sheet containing all these marks of 100 students. That's it for the day. Thank you everyone for watching this video.